So, how's everybody doing?
Great.
Good conference so far? Learning everything? All right. So, if you've never heard me before, my name is Dr. Kevin Connors. I practice in Minnesota, hence my accent, but people can have a Norwegian accent up here, don't they? A little bit? So if I say you betcha, or anything like that, you know why. I see mainly cancer and Lyme patients, some really sick autoimmune patients. I have a pretty good website. If you haven't been on our website, probably have at least 100 videos on our website. I like to teach, so hopefully I can make this really boring subject exciting today. I'm open to teaching whatever you want to learn about, so we're going to open up to some questions, and if you have specific questions to what I'm talking about, feel free to ask them, but I might not be able to get to everybody. So we're going to be talking about some hidden causes of disease, and we're going to be talking about genetics. Doesn't that sound fun? Woohoo! Yes. So your DNA as a hidden cause of disease. All right, are you ready?
We're ready.
I was really nervous. I told my staff, I said, oh man, I got about 60 slides and it's going to be all on genetics. I'm just afraid I'm going to bore everybody to tears. So I see there's only a few open seats. By the time I'm done, it'll probably be half empty. So I'm going to apologize right up front. So I really like looking at people's genes. And after I talk, hopefully you'll go, wow, I want to look at my genes too, because it can make a big difference in getting a person better. Most of my patients that come to me are in a situation where they're either really sick, stage 4 cancer. That's about 80% of our cancer patients come in as stage 4. They've tried chemotherapy, they've tried radiation, they've done surgery, and they've been given a timeline, most of them. And I'm not a healer. I believe I'm just a doctor, which I believe my responsibility is to pray for wisdom constantly, and then to walk in that wisdom as best I can, and just be in one of the things when I pray for wisdom for myself is that God always drives me to study. So when we talk about genetics, I have some comp gene defects that you'll see a little later, so I'm a little OCD with my studying, and I have no other life. But that's the way it is. But I like it. So we go on a vacation, and my wife says, okay, lay down and rest for a little bit. That lasts for about 5 minutes, then I have to get up and read a book. So that's just the way God wired me. So when I see patients that have gone everywhere else and can't get better, boy, that's a heavy responsibility. And to me, that is a responsibility. So when God sends us a patient, I believe that in a certain sense, I got to figure this out. And so I'm always searching for other missing pieces of the puzzle. So when we talk about genetics, I think this is a big missing piece of the puzzle in a lot of people's cases. They've gone to functional medicine doctors, they've gone to good functional chiropractors and naturopaths, and they've done, adrenal work and thyroid work and all this different kind of stuff, but there's something that they're missing. So I've spoken at other Rife conferences and talked about immunology. That's another big missing piece of the puzzle that I believe that most doctors don't understand. We're not going to be able to talk about that at this time. We don't have the time. But go on our website. If you have Lyme disease, I have a lot of really good videos on what I believe that there's 3 stages of Lyme, not just 2, that will help you understand that. Also, I have books out there. I think I only have the cancer books left. But please note, on our website, all my books are downloadable free. So you can get my books for free on our website. Yes. What's our website? Right there. www.connorsclinic.com. So I give all our information for free. So this video that's going to be made here, I'll get it and I'll actually put snips of it up on our website too, because I really believe that an educated person can take responsibility for their own disease and can make better decisions. So I do not want to be in a codependent relationship with my patients. I don't want them to depend upon me. I want to educate them as much as I can so that they can make their own decisions. So I try to put all my information up on our website. So I think you can spend about 2 weeks on my website just watching things. It'd probably kill you from boredom, but you could do that. So when we talk about genetics, we want to look at your genes. So how do we look at somebody's genes? So there is a real nice test out right now, if anybody has had this done. It's called the 23andMe. Has anybody run their 23andMe test? Just a few people. After today, there'll probably be a whole bunch more people running it if I do a good job. Now understand, I don't make any money if you run the 23andMe test. You go to 23andme.com and there's instructions on our website. So on my website I have tabs across the top and there's a tab that says genetic testing. I actually have a video under that tab telling you how to go to 23andMe and order your genetic test. So 23andMe is simply a lab. They'll send you a kit. It's a saliva sample. You can do it at home. They have excellent instructions. You register your kit. You spit in this tube. You send it back to them. And they'll send you an email saying, thank you, we got your kit. We'll let you know when your test comes back in. When you get the results back from them, they'll give you all this nice fluffy data that you're 12% Germanic and 6% Norwegian. And oh, I didn't know I had any French in me, but I don't care about any of that stuff. So what we need to see is your raw data. So I take your raw data and look at that and put it into a program, and that's what we're going to be talking about today. You won't be able to see any of this information that I'm talking to you about from your 23andMe yourself as a layperson. You have to go to a doctor that's going to extrapolate the raw data. So that's what we're going to be talking about. Does that help? All right. So that's how we look at your genetics. Last time I was here, I believe we talked a little bit about gut health. And the genetics tell us a bigger story about your gut. So our software that we put your gene profile in, and remember, genetics, your 23andMe is running thousands of different genes, takes those genes and separates them into components that affect different parts of your body. So the first section that we talk about when we look at your genes is the health of your gut. Now, is the health of your gut really important? Yes. And understand, I see a lot of cancer and Lyme patients, and many times they'll ask that question, what does my gut have to do with my breast cancer? I don't have any digestive problems. What does this have to do with anything? And my answer back is, really, the health of your gut, you could argue that many diseases, matter of fact, you could probably argue that most diseases can begin with the gut. So by the gut, we're talking about your stomach and your intestinal tract. So we really do need to look at the gut. And there's some genetic pictures that help us look at the gut. So our first section when we look at your 23andMe profile, when we look at your genetic profile, are those genes that affect your gut. Now understand, when we look at your genes, these are your genes. You were born with them. They're not going to change typically. So when we're not going to run another 23andMe profile in a year to see if your genes change, because they won't change. So you get your genes, one allele from your mother and one allele from your father. And then that is what you have inherited. Now there is what are called epigenetic defects. An epigenetic defect can be a defect in a gene due to environmental influences.
Please say that again.
An epigenetic defect. You're actually taking notes? So an epigenetic defect is a defect that happens because of environmental influences. I work in an ammunition plant and I'm working with mercury and aluminum all day long. It can affect my genes. So I can have a defect on my genes because of an environmental influence. I worked in Chernobyl for a year measuring radiation and it affected my genes. Follow me? So I once had a patient who was from Russia. And her gene profile, she actually did not have cancer, but her gene profile was the worst I've ever seen. And I said, oh, I want to do a study on you because this is really interesting. This is the worst I've ever seen. She had more double allele defects, meaning a defect from both parents, than I've ever seen. I said, what was your history? She had been in the United States for 30 years or something like that. Well, her father actually had cancer twice, and her father was the head of an agricultural, big, giant industrial farm in Russia, and his whole responsibility was mixing the chemicals. So I said, oh my gosh, I would just love, and her father, I believe, was deceased, and her grandparents were deceased, but I would have loved to see a genetic profile on her grandparents that lived prior to this exposure, and then her father, and then her, and her siblings as a study. Now understand, this availability of these gene profiles has only been in the last few years. So we don't have necessarily that ability. And her parents are now deceased, but it would have been really interesting. I would have put money on her grandparents not having those same gene defects. So in a sense, chemical exposure, radiation exposure, etc., that's affecting our genes, including medications, vaccinations, etc., we are damaging our gene pool as a species. It's pretty sad, especially when you look at as many gene profiles as I do. It's like, oh man. So there are some of these genes that we're going to look at that you can have an influence on nutritionally, especially the ones when we're talking about the gut. There's much nutritional influence that you can have on these. Some you could use specific nutrients that can help push those gene pathways that have defects on it, and some are dietary, some are lifestyle changes, some are easier to affect than others. Some are not very easy to affect at all. And that's what makes it sad. So unfortunately we live in a fallen world, and there's more chemicals that we're exposed to on a daily basis, even if you're trying to eat organic and do everything right. But the fact exists that you're still exposed to just enormous amount of stuff no matter how hard you're trying to be healthy. So the first genes that we look at from a dietary standpoint are these HLA genes. So this is that's a little snippet, that little clip is a clip from my software. So a patient would receive a whole giant printout of about 30 some pages that we would look at. And it's very daunting, really, from a patient perspective. So I try to explain it. And understand, I require all my patients, if we're going to go through a genetic profile, to watch my videos under the genetic tab, which is a little daunting in itself. But if you watch them a few times, you start, and I'm not trying to say that you have to be like knowledgeable in all this, but it's almost like we're speaking a little different language. So the more you can know, I think the better you can understand why I'm making recommendations. So these first HLA genes are genes that affect gluten sensitivity. So when you look at this profile, like we're going to see a whole bunch of these SNPs if you stay with me for these few hours. It has the gene there, the HLA-DQA1, and then the gene name after it. You see the top one on there? And then there's a blank, because this particular individual, who I cut and pasted this off of, does not have a defect there. So you want to have a blank here. Does my pointer work? Oh, it doesn't work on the screen. Great. So you want to have a blank after where it says in the column of variant. I use the term defect. That's because I'm used to using that. A better term would be variant, because some of these variants can be actually beneficial to have. Most of them aren't. So that person does not have a variant in that particular gene. These are the known genes that affect gluten sensitivity. Now I think somebody's going to be talking about gluten sensitivity in a little bit, so I'll leave this alone. But when I see a genetic profile like this, and the person has a double allele defect in that bottom one, do you see that? So they have a 2 there. So they inherited a gene from their mother and from their father. And a single allele defect in that middle one, do you see that? So, as you're going to see some other categories of genes that we're going to talk about, when this particular individual has a smattering of defects throughout all the genes, I would say this isn't all that bad. But when a person has any defects in this, I would say you shouldn't be eating gluten from a genetic standpoint. So everything we're going to be talking about today, and if we do a gene profile on you, we're only talking about your genes. So there are other reasons why a person should change their diet. So a person could have no defects in their HLA genes for gluten and yet still have gluten sensitivity. Because gluten sensitivity has to do with an immune reaction to the peptides of the protein gliadin, and it really has much less to do with a genetic predisposition. Follow me? But that's a lecture in itself, and I'll save that for another person. So the MCM6 gene has to do with lactose intolerance. Now I don't usually take people off of dairy because of lactose anyhow. We take people off of dairy because of the protein in dairy, casein, and they have a sensitivity to that because they have an immune sensitivity to it. We're not really looking at the genes. So really when I look at a person's gene profile, we pretty much ignore this first piece, except it does give me some gravity to push them to what I already tell most people to go on a gluten-free diet anyhow. Because inflammation in the gut equals inflammation in the brain. And inflammation in the brain equals problems in the rest of the body. So if you're not already gluten-free, and we're going to have a lunch here in a little while, and it's probably going to be bread. I believe I fall into the category that I think everybody should be gluten-free, because it's highly inflammatory to your gut. And when you have inflammation in the gut, you have inflammation in the brain. So we'll move on. This also tests for peanut allergy genes. Now, I don't see people particularly for allergies anymore. I see mainly cancer and Lyme patients, and even this person doesn't have a known peanut allergy, but she has 2 defects, single allele defects in both the peanut allergy genes. Now also, if you're fairly compromised health-wise, you probably shouldn't be eating peanuts anyhow because they have a lot of mycotoxins and mold. Nobody should really be eating a lot of peanuts, right? But certainly if you have the defects, you should not be eating peanuts. Okay? Still with me? All right. So there is some genes for caffeine consumption and how well you detoxify caffeine. That's that last one, that caffeine metabolism. This person has a double allele defect. In this particular case, this variant actually helps you detoxify, metabolize caffeine much quicker. Before we had the gene profile, I'd say, is caffeine good for you or bad for you? Well, does caffeine make you have to go to the bathroom? Yeah, I drink about 3 cups of coffee and I'm running and I have to go urinate. Well, then you have the gene that metabolizes caffeine very quickly, and caffeine isn't necessarily bad for you. No, I could drink a whole pot of coffee. It doesn't make me go to the bathroom. Well, then you shouldn't be drinking coffee. Okay? But now we can look at the genetic picture and say, should you be drinking coffee or shouldn't be drinking coffee? And this person would be fine drinking a little coffee. But if you had a blank there, then you probably shouldn't be drinking very much coffee. Follow me? But that's just kind of a fun one. That's not what we're dealing with, real health or not. Now we start to get into real sickness. Your FUT2 genes, actually now in the new gene profiles, now understand the software that we use, we're constantly adding new genes as discoveries are made. Because this is literally a new science. So new research is coming out literally daily on what the different genes do. So we did this Human Genome Project, in America. They gathered all this information of all the different genes, and they realized that there's a whole lot less than they thought there was, and now they're trying to figure out what these different genes do. The FUT2 gene's responsibility is very important when it comes to your gut. Because your gut health has to do with a number of different things. The cells of the intestinal tract have to be tightly packed together. That's how they are when you're born. And they only allow things through that you have receptors for, or that are small enough that can sneak through between the cells. So if we have a healthy cell membrane, a healthy cell wall, a healthy cells of the intestinal tract, then we're going to have a healthier disposition overall. However, there's all sorts of things that damage our gut. So there's genetically modified foods that damage our gut. There's inflammatory things that damage our gut. Medications, chemicals, yada, yada, yada. There's a zillion things that damage our gut. When we have a damaged gut, I said that can equal a damaged body because, remember I've said in the past, you are what you absorb, right? So you aren't just what you eat, you are what you absorb. Let's use an example. Well, I'm not supposed to eat a lot of fish from Lake Michigan because it has mercury in it, so I better not, I'm limited to the amount of fish. Actually, do you have absorption sites in your gut for mercury? No. But do you probably have a damaged gut that mercury is going to be able to leak through and get into your bloodstream? Yes. So if you had a perfectly healthy gut, eating some mercury in your fish shouldn't bother you. You should expel it into the toilet. However, when I have a damaged gut membrane and my epithelial cells of my gut are spread apart, a lot of things get through that weren't supposed to get through. Then I make myself toxic and I make myself inflamed because my immune system responds to these things that never should have been in my bloodstream in the first place, and my immune system goes, what in the heck is that? Let's kill it. And it fires an inflammatory response. When there are food particles, peptides of gluten and other things, and heavy metals and toxins and things like that, those things don't die when your immune system tries to kill it, and all you do is have this systemic inflammatory process going on. Follow me? Health of the gut equals health of the body. When you have inflammation in the gut, you also have inflammation in the brain. So it's really important to have a healthy gut. Your FUT2 genes, now, there's only 3 listed here. Now in our new reports, I think there's 20. These are responsible for making an enzyme that makes the healthy mucosal layer that lines the intestinal tract. So the mucosal layer that lines the intestinal tract, you can think of as the apartment building for your microbiota to live. So your microbiota are your normal flora, the good bacteria that live symbiotically in your gut, that help kill off pathogens, that help keep a balance. You guys still with me? Okay. So if I have FUT2 gene defects, like this poor person right here, double allele defects in all 3 of them, they do not have the carpenters to make a healthy apartment building for the microbiota to live from birth. So even let's pretend, give this person the best case scenario. They had a mother who did not take drugs, did not ever take antibiotics, inherited through the mother's breast milk a wonderful microbiota, that normal, healthy floral layer. So they have a perfect microbiota. The mom did not give her antibiotics at all during her early years, which would destroy the microbiota. Let's pretend they have a perfect microbiota, but they have these FUT2 gene defects, so they don't make a really healthy mucosal layer. And now they get Lyme at 23 years old, and they go on doxycycline for early Lyme, which really, in my book, would be the right thing to do. But it also wipes out the healthy microbiota that they had. And now having FUT2 gene defects, it's very hard to get that back. So the people that we see with FUT2 gene defects have a very difficult time with chronic health conditions, because they have a very difficult time keeping a healthy microbiota. Yes?
So what do you suggest for them?
So what do we suggest? You're getting ahead of us. So this is very important. These FUT2 genes are really super important. And with the patient base that I see, we see people that have a lot of defects here. Not all of them have double allele defects in all of them. This person is really having a difficult time. So then you go back to last year's Rife Symposium to learn how to heal the gut. So how do you heal the gut? You have to use specific nutrition that's going to heal the gut. You have to use prebiotics as well as probiotics. So most people think, oh, I got a bad gut, so I'm going to take some probiotics. And it just doesn't seem to make my gut better. And understand, this person right here with this gene defect might not have any quote-unquote gut symptoms. So that's the beauty of looking at labs, is that you bypass the person's symptomatology. So they might not have any symptoms, but they still have issues that we need to address. This person with a gene defect like this, how would you treat it? They need to be on some gut nutrition. They need to be on a prebiotic. They need to be educated on what prebiotics are in their normal diet. And they need to be on a probiotic. Possibly doing probiotic enemas, retention enemas as well. We need to heal their microbiota. So there's multiple avenues in this, and we have a bunch of videos on this on our website, because we're doing this with all our patients. The question over there first, does that answer it? Perfect. Yes?
Can you get enough prebiotic fiber from your diet? Or
Can you get enough prebiotic fiber from your diet? Normally you can. If you're eating good, you're eating some green bananas, you're eating some raw onion family foods, you're eating some raw dandelion leaves, you're eating some chicory substances, things like that. Those are all good prebiotics. If a person has a lot of FUT2 gene defects, I think they should supplement. We use a product that I developed called Sun Spectrum that has a modified guar gum that statistically, from all the research, is the best prebiotic on the market. But again, a prebiotic is simply helping to feed those epithelial cells. If you continue to have inflammatory processes going on in the gut, like you continue to eat poorly, you continue to eat genetically modified foods and gluten and all these inflammatory things, even though they don't cause any problems, quote unquote, they are. So then it's a losing battle. So you do have to make those changes as well. Yes?
Fermented foods, prebiotic?
Is a fermented food prebiotic? No. So fermented food has probiotics, but you're going to see in a little bit, if you have specific gene defects, you got to be very careful with those. And if you're going to use a fermented foods are a phenomenal source of probiotics. I always tell my patients that just a couple tablespoons of raw sauerkraut has more probiotics than your entire bottle of probiotics does. However, you have to be careful with fermented foods because they contain a lot of histamine. And if you have ABP1 gene defects that we're going to see in a second, or HNMT gene defects, you can't use fermented foods. That help? So this person needs some support of their gut. Still with me? Yes?
Would you use like a flora, is that the prebiotic?
A flora, is that the prebiotic? So the flora is the old term that's used that is now, we call the microbiota. So I don't know what you mean by flora.
Well, I thought I read a long time ago that you should do the flora or the micro one for 2 weeks before you started your probiotics.
So they're probably, she said you should use something for 2 weeks before starting your probiotics. They're probably speaking of a prebiotic. That's probably what they were speaking of.
Do you think that's right to do?
I think you could do it concurrently. I don't think there's a problem with that. So we put people on a product that uses it concurrently. These are your ABP1 genes. The ABP1 genes that affect histamine. So histamine is an inflammatory product that your body normally makes, but it's something it's a chemical that's in a lot of different foods as well. The ABP1 genes are the genes that make the DAO enzyme that breaks down histamine in your gut and partly in your blood. Very, very important gene, because this tells us whether the person can use fermented foods. And by the way, side note on fermented foods, if you have a lot of leaky gut issues, you can't use fermented foods right away either, because they'll cross the gut in the larger molecules will cross the gut border and cause inflammation in the blood and the tissues. So you've got to do some work on healing the gut many times, not all the time, before you can start using fermented foods. So if a person has these gene defects, and this person has double allele defect on one, I would be careful with this person using fermented foods. So your ABP1 genes are really important. As a matter of fact, people with ABP1 gene defects, and then this next family, this HNMT gene defects, this can be this right here, the first part of the report, can be the main cause of the person's symptom problems right here. So HNMT gene, these genes get rid of histamine in the tissue. Now again, you normally produce histamine. Histamine is an immune chemical that's produced in the presence of an antigen or an allergen in your body. And it has a purpose, a very good purpose. But it's supposed to have a very short half-life. Why? Because the HNMT genes are making an enzyme that break it down and get rid of it, so that it's out of your body. It does its job and it's out of your body. Now remember, almost everything that we're going to talk about here, everything in your body is about balance. It's all about balance. There's not necessarily good guys and bad guys, right? The bad guys are only bad guys when they're out of balance. The good guys can be bad guys when they're out of balance. I'm going to take a bunch of antioxidants because I don't want any oxidation in my body. Well, then you're going to die of cancer. Okay? You have to have some oxidants and free radicals in your body, because that's what kills pathogens and cancer cells. But when you have too many, they can cause cancer. Follow? It's all about balance. So just if I give a patient here, I want you to take 3 of these a day, and they go, well, I'm going to take 10 because that would be better, because we're Americans, that can be bad. So it's all about balance. Yes?
I'm just wondering if you're sure those variants there are truly problematic. In other words, not benign polymorphism.
So good question. Do we know that these variants are truly problematic? Just by looking at the gene profile, we do not. So there's other things that we can look at that I was going to put in the slide presentation too, but I thought, not only I bore you to death, I would literally kill you. There's some other tests that we can run, an organics test that we can actually look at histamine levels. The only problem with those, the genetic test doesn't change. The organic test changes, rapidly, because it's your current snapped photograph of your body chemistry that can be different right now compared to 3 hours from now. So that's the only variant in there.
Just one thought on it. I ran my 23andMe through MTHFRsupport.com, and I thought, oh, I've got G6PD because I've got 2 double mutations. I looked them up, and they're just normal benign polymorphisms that mean nothing, so I don't have G6PD, and I did the quantitative test. But I'm just wondering if you see, these couple things, and you think, oh, it's bad, but it's just a normal polymorphism. Sure, you can do your OAT test to verify, but I'm just wondering if you know for each of those genes if they are benign, silent.
So what he's saying is, do everyone, when a person has gene defects, does that mean that they're doomed? Does that mean that's causing a symptom pattern in their body?
I'm more asking, let's say you take the top line and there's a defect in there, could it be that doesn't affect the HNMT in any way?
Okay, so with our 20 seconds we have left, remember one thing. That defect in that gene does not mean that that gene is not working completely. And we don't even know that just because there's research on the MTHFR 677 gene that we'll talk about later, that a double allele defect decreases its function by 65%. That's on average. And even at that, it's still working. So it doesn't mean you're doomed to that disease or you're doomed to a problem with that. It just means that we do have compromise in there, especially with a greater amount of defects in a family. That's all we can really say. So the environment trumps everything. So if your environment is good, then you're going to have less problems with that gene profile. Now, again, if a person's coming to me, typically they have symptoms. So then we want to clarify their genetics with their symptoms and really get a better picture on what we want to support. Does that help? So there's no guarantee that just because I have defects that I'm going to absolutely have problems, but there's also no guarantee if I have 0 defects that I'm not going to have a whole host of problems. Because just because I don't, let's say this person is actually really, really good, actually, in their HNMT, but I have had people with single and double allele defects on almost every one of those. The chance of that person having histamine clearing problems is like through the roof. Does that make sense? So you want to address it.